Example number 1, find domain and range of the function f of x is equal to square root of x minus 5. So here now we know that the square root function is defined only for positive values. So here domain positive values and 0. So domain is equal to a collection of all real numbers such that x minus 5 is greater than or equal to 0. So this implies it is equal to collection of all x belongs to real number set R such that x greater than or equal to 5. So here domain is equal to 5 to infinity. Okay, and what is the range? We know that for square root function the range is 0 to infinity here. So what is the range? Range is equal to 0 to infinity. Now number 2, prove that if a divides say b and b divides c, then a divides c. So we know that if a divides b implies b is equal to ak1 and b divides c implies c is equal to ak2, and so put the value of say, okay, we want to show that a divides c, sorry, here b is c is equal to bk2. So put the value of b in this equation, we get c is equal to a times k1 k2. Say k1 k2 is equal to k3, so c is equal to a k3. Now here c is multiple of a and this implies a divides c. Example number 3. Okay, example number 3. Okay, so we want to write any partition of set say a b c d. So here we can write a partition, say the set a is equal to ab and set b is equal to say cd. Then the a union b is equal to the abcd whole set, and a intersection b is equal to empty set. So this is the partition of, this implies a and b, set a and b form partition for set a b c d. There are so many partition you can okay. So example number 4. Okay, we want to determine number 4. Suppose set a is given, a is equal to 1 2 3. Okay, and we want to write down a relation which is reflexive transitive. Say find relation on set a which is reflexive, say transitive but not symmetric. So we want to determine a relation on set a is equal to 1 2 3 which is reflexive, symmetric but not transitive. See here the relation R is equal to, since we want a relation should be reflexive, so I am writing here 1 1, 2 related to 2 and 3 related to 3, and we want the relation should be transitive, so I am writing here 1 2 and 2 say 2 3. Okay, then 1 and write down one more pair, say 1 3. So you can check this relation is transitive, 1 related to 2, 2 related 1 3 is there. Okay, so this is transitive, okay, but not symmetric. This is not symmetric. Why? symmetric, you can check 1 related to 2 but 2 does not related to what 1, so this is not symmetric. Number 5, okay, you want to determine addition and multiplication table. Find addition and multiplication table for Z4. So we know that Z4 contain all the equivalence classes modulo 4, so it contains 0 bar, 1 bar, 2 bar, 3 bar, so it is equal to so the addition modulo I want to determine addition modulo 0 bar, 1 bar, 2 bar, 3 bar, and this is equal to 0 bar, 1 bar, 2 bar and 3 bar. So 0 bar plus 0 bar is 0 bar, 1 bar, 2 bar, 3 bar, here 1 bar, 2 bar, say 3 bar, then 1 bar plus 1 bar is 2 bar, 1 bar plus 2 bar is 3 bar, and 1 bar plus 3 bar 4 bar, which is equal to what? 0 bar. Then 2 bar plus 1 bar is 3 bar, 2 bar plus 2 bar is 0 bar, and 2 bar plus 3 bar is 5 bar, which is equal to 1 bar. 3 bar plus 1 bar is 0 bar, 3 bar plus 2 bar is 1 bar, 3 bar plus 3 bar, which is equal to what? 2 bar. Similarly, for multiplication table, say here say for multiplication, say 0 bar, 1 bar, 2 bar and 3 bar, it is equal 0 bar, 1 bar, 2 bar and say here 3 bar is equal to 0 bar into 0 bar is 0 bar, 0 bar, here 0 bar, 0 bar, again 1 bar into 0 bar is 0 bar, 1 bar, 2 bar, 3 bar, here 0 bar, 2 bar, 2 bar into 2 bar is 2 bar into say 2 bar is equal to 4 bar, which is equal to congruent to what? 0 modulo 4. So here it is 0 bar, and 2 bar into 3 bar is equal to 2 into 3 bar, which is equal to 6 bar. So this is equal to 6 bar, which is congruent to what? 2 bar modulo 4. Similarly, 3 bar into 0 bar is 0 bar, 3 bar, 3 bar into 2 bar 6 bar, which is 2 bar, and 3 bar into 3 bar 9 bar, and 9 bar, say here say 3 bar into 2 bar is 2 bar, 6 bar, and 3 bar into 3 bar is 9 bar, which is congruent to what? 1 bar modulo 4. So it is equal to here 1 bar. Now next example, let f say here let function f is a function from, say example number, say f is a function from real number set to real number set, that is it is a real valued function defined as f of x is equal to say thrice x plus 4, then show that that is want to check whether is f invertible, want to check whether f is invertible. So when we said a function is invertible if it is 1 1, so and on to, so if f of x is equal to f of y implies thrice x plus 4 is equal to thrice y plus 4. So if we cancel this 4 we get thrice x is equal to thrice y, and this implies if we divide by 3 both sides we get x is equal to y. Similarly, now for onto function, therefore from this we can say that f is 1 1. For onto function, let for say y belongs to R, suppose there exists say x belongs to R such that f of x is equal to y. If we are able to determine the value of x, then we can say that f is invertible. Okay, on two functions, sorry. So f of x is what? Say thrice x plus 4, the value of f of x is equal to y. This implies thrice x is equal to y minus 4, and this implies x is equal to y minus 4 divided by 3. So here f inverse, so f of y minus 4 divided by 3 is equal to y, and this is what? This belongs to domain set, and therefore f is onto, here f is 1 1 and f is onto, and therefore f is what? Bijective, and from this we can say that f is invertible. Okay, now next example, say if a congruent to, next example, if a congruent to b modulo modulo n, then we want to show that am congruent to bm modulo n, where m is any non-zero integer. So or m is any integer. So say here now since a congruent to b modulo n implies n divides a minus b, and this implies a minus b is equal to nk. Now if you multiply both side by m, we get m into a minus b is equal to mnk, say here mk times n. Okay, say here this is equal to m a minus mb is equal to, okay, n times, say this is equal to k dash, and this implies n divides ma minus mb, and this implies ma congruent to mb modulo n. So this is what we want to prove. Now next example, say okay, determine, say find the value of, say 100 and, say find the value of 101 bar in Z3. So now if we divide this 101 by 3, then we get the remainder is equal to what? Remainder is equal to, say 2. Okay, so here the 101 bar congruent to 2 bar modulo 3, and therefore 100 and the value of 101 bar is equal to 2 bar in Z3. Okay, the next example, okay, find the value of, calculate 2 bar into 9 bar, okay, plus 1 bar raised to minus 1 in the find the value of this term under Z12 modulo plus. So in this set we want to determine the value of 2 bar into 9 bar plus 1 bar under addition modulo 12. So here 2 bar into 9 bar, 2 bar into 9 bar plus 1 bar is equal to 18 bar plus 1 bar is equal to 19 bar, and which is equal to 19 bar is equal to, say 19 bar congruent to what? 7 bar modulo 12. And now we want to determine the inverse of, that is we want to determine 7 bar inverse. Now that is we want to determine the value of x bar such that the 7 bar plus x bar is equal to what? 0 bar. So it is equal to, so x bar is equal to here if we take x bar is equal to 5, then 5 bar, then we get 7 bar plus 5 bar is equal to what? 12 bar, which is equal to 0 bar, and therefore the value of this term is equal to, say 5 bar. So what is answer here? Answer is equal to 5 bar.